Let's talk about DNS, the domain name system. It's one of those amazing invisible technologies that's just quietly running the entire internet in the background. As a developer, you're bumping into it constantly, every single day, whether you're pushing code or just browsing the web. It's an absolutely fundamental piece of the puzzle. And today, we're going to pull back the curtain and map out exactly how it all works. Think about it for a second. You do this dozens, maybe hundreds of times a day without even blinking. You type a web address, hit enter, and poof, a website appears. But that simple keystroke, it kicks off this fascinating, super high-speed journey across the internet. We're about to trace that entire journey, from start to finish. So to really get why DNS is such a big deal, you gotta look back at how things used to be. We're talking about the early days of the internet, ARPANET. Back then, there was no slick, automated system. Instead, everything relied on a single file, hosts.txt. Seriously. If you wanted to add a new computer to the network, you had to literally call the Stanford Research Institute, during business hours, of course, and have them manually add it. As you can imagine, this whole system was slow, super easy to mess up, and just completely unscalable. Okay, let's place this on our roadmap. The huge problem of that one clunky text file in the 70s led to a truly brilliant solution in 1983. A guy named Paul Mockapetris at USC invented DNS, a system that was specifically designed to be distributed, automated, and able to grow with the internet. And by 1985, it wasn't just some cool idea, it was an absolutely essential part of how the internet works. And it still is today. So if there's one thing you take away from all this, it's this. DNS is, quite simply, the phone book of the internet. It's a perfect analogy. We humans, we're good with names, right? Like developerroadmaps.com. But computers, they talk to each other using numbers, these IP addresses. DNS is that critical translation service that connects our world of words to the network's world of numbers. All right, so your browser has the name, but what it really needs is the number. To get it, it sends out a request, and that request is called a DNS query. Let's map out the incredible journey of that one little query on our roadmap and see exactly where it goes. To really understand this journey, we need to meet our two main characters. First, you've got the recursive resolver. Think of it like a super helpful librarian. It takes your request and basically says, I got this, I'll do all the running around and find the answer for you. Then you have the authoritative name server. This is like the dictionary itself. It's the source of truth. It holds the definitive, correct answer and doesn't need to ask anyone else. The librarian's job is to find the right dictionary. So this slide maps out the whole path. Let's walk through it. Your request first goes to our librarian, the recursive resolver. Now, the resolver probably doesn't know the answer offhand, so it starts at the very top of the DNS food chain by asking a root server. The root server doesn't have the IP either, but it knows who manages all the .com domains, so it points the resolver to the top-level domain, or TLD server, for .com. The resolver then asks the .com TLD server, which in turn points to the final destination, the domain's authoritative main server. That's our dictionary, the one that holds the actual record. The resolver finally gets the IP address from that server, passes it back to your browser, and boom, mission accomplished. The website can now load. Now, that 8-step journey seems like a lot of work to do every single time you visit a website, right? And it would be, except the whole system has a very, very clever shortcut built right in. And that shortcut is caching. It's a simple but brilliant idea. Instead of just throwing the answer away after finding it, different parts of the system will store a copy of it for a little while. What this means is, the next time someone asks the exact same question, they can get the answer almost instantly, without having to make that entire trip all over again. And this caching doesn't just happen in one place, it's happening at multiple levels, which creates all these opportunities to speed things up. Your own web browser is the very first place it checks. If it's not there, it checks your operating system's cache. And if it's still not found, the query goes out to your ISP's recursive resolver, which, you guessed it, keeps its own massive cache of recent lookups. Each step is a potential off-ramp from that long 8-step journey. But wait a minute, how does a cache know when the information is too old to be trusted? Well, that's controlled by something called time to live, or TTL. It's basically an expiration date stamped on the data. The domain's administrator sets this value, and it tells all the caches out there exactly how many seconds they can hang on to this record before they have to go back and ask for a fresh copy. It's this constant balancing act between performance and accuracy. This slide really drives home just how powerful caching is. I mean, look at the difference. The uncached lookup is that full 8-step journey we mapped out. But a cached lookup, as you can see, it's a quick 2-step deal. Your browser asks the resolver finds the answer right there in its cache and immediately sends it back. The difference in performance is just enormous. So, we've traced the journey and we've found the shortcuts. But let's bring this back to your roadmap as a developer. Why is this a critical checkpoint? How does knowing all this actually help you build better applications? First up, performance. When you control a domain, you also control its TTL values. Knowing how to set those properly can directly impact how fast your site feels to your users. Second, debugging. When a domain just isn't working, knowing this whole lookup process lets you use tools like dig or NS lookup to trace the query yourself and pinpoint exactly where things are breaking down. And finally, it's just about infrastructure awareness. DNS is a foundational layer of the internet. Understanding it means you truly understand the ground you're building on. And that brings us to a final thought here. DNS has served us incredibly well for decades, but it was designed back in 1983 for a very different kind of internet, one that was mostly made up of trusted academics. It just wasn't built for the global, commercial, and often hostile network we have today. With all our modern challenges, things like privacy and security, if you were tasked with designing a naming system from scratch for today's internet, what would you do differently? This is Developer Roadmaps. Map your path. Build your career.